Hi, my name is Harkishan Singh, and first we will talk about graphical analysis. Numerical variables have data that can be easily arranged in a logical order and can be measured. It can either be in continuous form or in discrete form. The only difference between the two is further dividing it into smaller parts. Categorical variables have data that can be sorted into different groups and can be observed. If categorical data have numerical data, these data do not have any meaning. The above graph represents the numerical variable in graphical form. For plotting the numerical variables, histograms, dot plots, scatter plots, and leaf and stem graph can be used. Histogram for numerical variables do not have a gap in between and are continuous. This graph represents the categorical variable in a graphical form. It uses a pie chart and histogram for plotting. The histogram for categorical data has gaps in between.
Good morning, Professor. Here's Satvir Korgil, and my student ID is 20173363. Here I would like to explain the rest part of our presentations. As I'll explain that the null and alternate hypothesis. As a null hypothesis is an original statement where there is no change in the set of variables and it is donated by HO and is always tested, and the researchers try to disprove the null hypothesis, and it cannot be accepted easily just based on a single test but can be easily rejected. It has implicit and indirect test. Otherwise, the alternative hypothesis claims a good amount of change in the set of variables and is used for testing of hypothesis. It is donated by H1 and approved by researchers in an indirect manner. The alternative hypothesis can only be included when the null hypothesis is rejected and it has explicit and direct testing. The next one is the simple linear regression model. A simple linear regression model is an approach in statistics that allows the evaluation of the connection between two quantitative variables. One of the variable is represented as x and another one that is independent and another one is y, and that variable is dependent. It is used to know the value of the dependent variable with respect to the independent variable and the strength of the variable. Here I would like to tell you that as per the regression statistics, the multiple R tells the strength of the connection between the variables. Here the value of the multiple R is 0.245, which shows that the strength between these two variables is not strong. R squares tells the model fits well, and the R value is 0.06, which is 6%, and it is a bad fit. And the adjusted R square adjusts the number of the variables, and standard error tells the distance among the variable and the values on the regression line, and which is 0.481. The observation tells that the number of the data here is a 25,976. The value p-value tells the whether the variable is statistically significant or not, and here the in-flight services is statistically insignificant, which is with p equals to o, while the intercept is statistically insignificant.
Hi, my name is Armila Rai and my student ID is 20173029. I'm going to explain slide 9, which is related to the assumptions and violation of simple linear regression model. Since the simple linear regression follow a parametric test, which means that some assumptions are made about the data, and these are: the size of the error in the projection doesn't change much with respect to the independent variable's value. The other assumption is about the normality of the data, in which the data is normally distributed and the observation made in the dataset was done by gathering statistics using sampling approach, and there was no relationship within these variables. The other assumption made was that the connection between the variables that are dependent and independent is always straight, and the line of best fitting that passes through the data is a straight line and not a curved line. Violation of the assumptions made in the model are: variables that are independent are additive in nature. The remaining variables are distributed normally. No connection between the data and remaining terms. Variables that are independent are correlated. There is consistency in the error term. The connection between variables that are dependent and independent is always straight. Multiple linear regression module can be used to know the value of the point that is dependent based on the point that is independent at a specific value, and to determine the stability of the connection between one dependent and two independent variables. This module tells one variable that is based on the information of the other variable. According to the multiple regression statistics, the multiple R tells the strength of the connection between the variable. Here the value of the multiple R is 0.329, which shows that the strength between these two variables is not strong. R square tells if the model fits well, the R value is 0.10, which is 10%, and it is not a good fit. The adjusted R-square adjusts the number of variables, and the standard errors tells the space in the point and the values on the regression line, which is 0.468. The observation tells the number of data in the data. Here the number of observation is 25,976. The p-value tells whether the variable is statistically significant or not. Here the in-flight Wi-Fi service is statistically significant with p equals to O, while the intercept, departure or arrival time, and the ease of online booking are statistically insignificant.
Good evening, guys. My name is Silp and my student ID is 20173299. Now I'm going to discussing about assumptions and violations of multiple linear regression model. A few of the assumptions of this model are: the observation made in the dataset was done by gathering statistics using a sampling approach and there was no connection between these variables. In this model, the independent variables may be interrelated and are checked before creating a regression model. Some of the violations are lack of independent variables in the model and lack of independence in the variable that is dependent. The performance of the simple and multiple linear regression model can be calculated using different performance metrics. Since the R-square value of multiple regression is much closer to 1 than the simple linear regression model, the multiple linear regression model fits the best. The significance level is represented, which measures the strength of variables before rejecting the null hypothesis and conducting if it is statistically significant or not. It determines if the null hypothesis will be accepted or rejected, and shows a 5% chance that the difference exists when actually there is no difference. The contribution made by independent variables in the simple and multiple regression models. In the simple regression model, one variable that is independent is statistically significant, while the other is not. In the multiple regression model, also one variable that is independent is statistically significant, while the other two are not.